Dear students, welcome. Today I am going to teach you coordinate geometry. In the last year, I took 12 classes in coordinate 12 classes for coordinate geometry. Out of these 12 classes, 5 classes were from the chapter change of axis, and the remaining 7 classes were from the chapter pair of straight lines. Now I am not going to repeat that classes. I am going to solve some problems which were not done in the previous classes. Today I am going to solve these problems. Very interesting problem and very important problem. If the lines, if the lines ax square plus twice xy plus by square equal to 0 be two sides of a parallelogram and the line lx plus my equal to 1 be one of its diagonals, so that the equation of the other diagonal is this. What you are given? You are given that this equation, it always represents a straight line represents a pair of straight lines passing through the origin. The two straight lines are of the type y equal to m1x. Let the two straight lines represented by these equations be y equal to m1x and y equal to m2x. The point of intersection of these two straight lines is obviously 0, 0, because both these straight lines pass through the origin. Both these straight lines pass through the origin. The two straight lines represented by the general homogeneous equation of second degree, both these straight lines pass through the origin 0, 0, and the line lx plus my equal to 1 be one of its diagonals. You know, in a parallelogram there are two diagonals. Equation of one diagonal is this, so that the equation of the other diagonal is this. We have to show that the equation of the other diagonal is this. Now, you see, this represents a pair of straight lines passing through the origin, and these two straight lines are two adjacent sides of a parallelogram. One diagonal is this, we have to find the other diagonal. Let us proceed. Suppose this is a parallelogram. This is a parallelogram. Suppose this is A, B, C, D, be a parallelogram. Suppose y equal to this, y equal to m1x, y equal to m2x. Be two straight lines represented by the homogeneous equation of second degree this. Obviously, these two straight lines pass through the origin. Therefore, the coordinates of A must be 0, 0. The coordinates of A must be 0, 0. Point of intersection between these two straight lines is 0, 0. And we are given that Ls plus my equal to 1, the equation of one of the two diagonals. Let us first draw the diagonals AC and BD. Suppose these are two diagonals, and suppose E is the point of intersection between the two diagonals. Now notice that Lx plus my equal to 1, one of its diagonals, it is either BD or AC. Clearly, LX plus MY equal to 1 is not the diagonal AC because the diagonal AC must pass through the point 0, 0. But the point 0, 0 does not satisfy the equation this. This means that LX plus MY equal to 1 does not pass through 0, 0. Therefore, the equation of the diagonal LX plus MY equal to 1, this must represent the diagonal, this one, BD, other diagonal. Let me first write. Let the two straight lines passing through the origin represented by the equation ax square plus twice hxy plus by square equal to 0, b y equal to m1x and y equal to m2x. Suppose these two equations are 2 and 3. Two equations are 3. Now, obviously m1 plus m2 equal to minus twice h by b and m1 m2 equal to a by b. The combined equation of 2 and 3 is y minus m1x, y minus m2x equal to 0. This means y square minus m1 plus m2 into xy plus m1 m2 x square equal to 0. This is number. 1 and 4 represent the same pair of straight lines. 1 and 4 represent the same straight line. Pair of straight lines. Therefore, comparing 1 and 4 we get. If you compare 1 and 4, we get 1 divided by, it is b, equal to minus m1 plus m2 divided by twice h equal to m1 into m2 divided by a. This means m1 plus m2 is equal to minus twice h by b, m1 m2 equal to a by b, and m1 m2 equal to a by b. m1 plus m2 equal to minus twice h by b, m1 m2 equal to a by b. Now, since 2 and 3 are two sides of a parallelogram, according to the question, be two sides of a parallelogram. Now, 1 and 2, now the straight lines, 1 and 2, no, not 1 and 2, it is 2 and 3, not 1 and 2, it is 2 and 3. Straight lines 2 and 3 are two sides of a parallelogram. Let the straight line 2 straight lines 2 and 3 respectively the equations of the sides, equation of the sides AB and AD of the parallelogram ABCD. Let the straight lines 2 and 3 respectively the equations of the sides AB and AD of the parallelogram ABCD. of the parallelogram ABC. Now you see. Parallelogram ABCD. Now the third line, Lx plus My equal to 1, the equation of one of the two diagonals. Given that Lx plus My equal to 1, suppose this is number 5, is one of the diagonals AC and BD. AC and BD. But this does not pass, but the diagonal AC, but the diagonal AC passes through the point 0, 0, passes through the point 0, 0, passes through the point 0, 0. From the diagram you can easily see. But 5 does not pass through 0, 0. Pass through 0, 0. Therefore, 5 does not pass through 0, 0. Therefore, the equation of the diagonal, it is not AC. BD is 3. BD is given by 5. Is given by 5. Equation 5 represents the diagonal BD. Diagonal BD. You see, what I am going to do, we are going to find the equation of the diagonal AC. Equation of the diagonal AC. We know that the diagonal AC passes through the point 0, 0. Passes through the point 0, 0. Also, it passes through the point E also. What is E? Is the middle point of AC, obviously. If the two diagonals AC and BD cuts at the point E, if the two diagonals meet at the point E, then E is obviously the middle point of the diagonal AC as well as the diagonal BD. We can easily find the coordinates of the point E, which is the middle point of BD. How we can find this? We can easily find the coordinate of B, because the equation of the diagonal BD, it is Lx plus My equal to 1. Y is equal to M1x. It cuts at B. B is nothing but the point of intersection between the straight lines. Y is equal to M1x and Lx plus My equal to 1. We can easily find the coordinates of B. We can, in a similar way, we can also find the coordinates of the point B, D. Coordinates of the point B. Therefore, E is the middle point of BD. E is the middle point of BD. That can be easily calculated. Easily evaluated. Now, what is AC? It is a straight line passing through 2 points, 0, 0 and the point E. Thus, we are going to find the coordinates of E. we are going to find the coordinates of E. What is this? Now let us. Now it's given by now. The coordinates of A is 0, 0 because it is the point of intersection. Since it is the point of intersection, it is the point of intersection. Between the straight lines, y is equal to m1x and y is equal to m2x. Y is equal to m1x, y is equal to m2x. Both these straight lines pass through the origin 0, 0. Now, B is the point of intersection. B is the point of intersection. Point of intersection between the straight lines. Point of intersections between the straight lines. Y is equal to m1x and Lx plus my equal to 1. Lx plus my equal to 1 and y is equal to m1x. Obviously, it was number 2 and it was number 5. It was number 5, yes. Solving 2 and 5 we get. Solving 2 and 5 we get. Solving 2 and 5 we get. What is this here? Solving 2 and 5 we get. Lx plus m1x equal to 1. L plus m1 into x equal to 1. This means x is equal to 1 by L plus ml1. Now 2 implies y is equal to m1 divided by L plus mm1. m1 divided by L plus mm1. Therefore, the coordinates of B will be 1 by L plus mm1, m1 by L plus mm1. Similarly, it is not going to be y. Similarly, C is the point of intersection between the straight lines. Y is equal to m2x and Lx plus my equal to 1. Solving this, that is equation 3 and 5. 3 and 5. C is the point of it is not C. D. It is not C. D. D is the point of intersection. D is the point of intersection between this and this. Similarly solving 3 and 5 we get. Similarly, in a similar way, solving 3 and 5 we get. The coordinates of B will be, we get that the coordinates of D will be just replace M1 by M2 here. 1 by L plus MM2, M2 by L plus MM2, M2 by L plus MM2. We have got the coordinates of B as well as the coordinates of D. Now, let the diagonals AC and BD, let the diagonals. Let the diagonals AC and BD meet at the point E. Clearly, E is the middle point of AC as well as B. Now, E is the middle point of BD. Therefore, the coordinates of E will be. Therefore, the coordinates of E now suppose it is let the coordinates of E be x1 y1. Suppose this is x1 y1 is the coordinate of E. Therefore, x1 will be equal to what will be x1? It will be equal to half into 1 by L plus mm1 plus 1 by L plus mm2. The coordinates of B is this. The coordinates of D is equal to this. Therefore, it will be like this. Which is equal to 2 times of L plus mm1, L plus mm2, L plus mm2 plus L plus mm1. MM1. This is equal to twice L plus M into M1 plus M2 divided by, you may write like this. Just take it as it is. Y1 equal to, it is half into, Y coordinate of B is, Y coordinate of B is this, Y coordinate of D is this. Therefore, you will definitely get this one. You will definitely get this one. This is equal to half L plus mm1, L plus mm2. It will be L m1, L m2. You may write L m1 plus m2. L m1 plus m2. M into m1 m2 plus m into m1 m2 plus twice m into twice m into m1 m2. You will get like this. Also, The coordinates of x can also be written as twice L plus, replace M1 by M2 by minus twice h by b. Twice h by b. M1 and other things should be written as usual, as it is. Now, right, y1 equal to, what is y1? y1. The coordinates of E, x1, y1. Now, y1 equal to 1 by 2, or you may write 2 times of L plus M, M1. L plus M, M2. And it is L into minus twice h by b plus twice M into A by B, twice M into A by B. You see, this 2 will be cancelled. This 2 will be cancelled. You will get B into L plus M M1, L plus M M2. You will get this one. And here also 1 by B minus HL plus AM. You will get this one. You will get this one. BB will also be cancelled. BB will also be cancelled. You will get AM minus HL divided by B into L plus MM1, L plus MM2. And similarly, X1, Y1, you have found Y1 is. Here also 2 will be cancelled. Here also X1 2 will be cancelled. Oh, I am sorry here. 1 by B. Minus twice it. Yes. M1 plus M2 equal to minus twice h by b. M1 M2 equal to A by B. 2 will cancel h by b. Just I have written B 2 times. Please remove this one. It will be minus HL plus AM divided by B will be here. B will come to the denominator. This is this. Here also X1 will be equal to B into L plus MM1, L plus MM2. It will be BL minus HM. BL minus HM. The coordinates of E is equal to this. X1 is given by X1 is equal to this, Y1 equal to this. Y1 equal to this and X1 is equal to this. Y1 equal to this, X1 equal to this. Now, AC is the diagonal, is the other diagonal, AC. We have to find the equation of the diagonal AC. We have to find the equation of the diagonal AC. We have to find the equation of the diagonal AC. We have to find the equation of the diagonal AC. Now, AC passes through the points A00 and EX1, Y1. Now, AC passes through the points A00 and EX1, Y1. A00 and EX1, Y1. Therefore, equation of AC is y minus y1. This is equal to y2 minus y1 divided by x2 minus x1 into x minus x1. The formula of a straight line passing through the 2 points x1 y1 and x2 y2 is y minus y1 equal to y2 minus y1 divided by x2 minus x1 into x minus x1. Here x1 is 0, y1 is 0. Here in this case x1 is equal, x2 is equal to x1, y2 is equal to y1, like this. This means yx1 equal to xy1, yx1 equal to xy1. Now x1 and y1 it is suppose number 6 and number 7. You may write like this. This is x1 equal to number 6, y1 equal to number 7. Put x1 from number 6 and y1 from number 7. And y1 from number 7. This means y. What is x1? x1 means this BL minus HL divided by B into L plus MM1 L plus MM2. This is equal to x into y1. What is y1? AM minus HL divided by B into L plus MM1 L plus MM2 L plus MM2 by 6 and 7. You may write here by 6 and 7. By 6 and 7. This means the denominator of these two terms will be cancelled. Y into BL minus HM. This is equal to x into AM minus HL. Which is the equation of the diagonal AC. Clearly, AC passes through the point 0, 0. You see 0, 0. The point 0, 0 satisfies the equation. This means that this is a equation of a straight line passing through the point 0, 0. Passing through the point 0, 0. Now you see. Which is the equation of the diagonal AC? Which is the equation of the diagonal AC? You may write which is the equation of the diagonal AC. Clearly AC passes through the point 0, 0. AC must pass through the point 0, 0. It is 0. The diagonal AC must pass through the point 0, 0. It also passes through the point x1, y1. Clearly, AC passes through the point 0, 0. The origin 0, 0. It must pass through. The coordinates of A must be equal to 0, 0. Perhaps you have understood this. It is very easy, very simple. What is our logic? Ax square plus twice xy plus by square equal to 0. It represents a pair of straight lines passing through the origin. Therefore, the equations of the straight lines represented by the homogeneous equation of second degree will be of the type y is equal to m1x equal to and y is equal to m2x. Clearly, m1 plus m2 equal to minus twice s by b, m1 m2 equal to a by b. The point of intersection between the two straight lines is 0, 0. We are given that the two straight lines represented by the homogeneous equation of second degree, the two straight lines are two adjacent sides of a parallelogram. we have supposed that the two adjacent sides of the parallelogram is AB and AD. Therefore, the coordinates of A is 0, 0. We are also given that LX plus MY equal to 1 is one of the two diagonals. We notice that this AC cannot be equal to LX plus MY equal to 1 because AC must pass through the point 0, 0, A 0, 0. But LX plus MY equal to 1, this line does not pass through the point 0, 0. Because 0, 0 does not satisfy the equation LX plus MY equal to 1. Therefore, the equation of the diagonal BD is given by LX plus MY equal to 1. Therefore, so far we have got the coordinates of A in the parallelogram ABCD. We have got the coordinates of A, which is 0, 0, and the equation of the diagonal BD, LX plus MY equal to 1. Also, equation of the adjacent of the sides of the parallelogram, AB is y is equal to m1x and AD is y is equal to m2x. So far we have got this one. Now, since now B, what is B? B is the point of intersection between the line y is equal to m1x and LX plus MY equal to 1. Therefore, B is the point of intersection between the two straight lines. Solve these two equations. We have got x and y in terms of L and M. Right? L, M, and of course M1. The coordinates of B is 1 divided by L plus M, M1 and comma M1 divided by L plus M, M1. Similarly, the coordinates of C can be found in a similar way. What is C? What is the coordinates of D? What is the coordinates of D? It is the point of intersection between the straight line y is equal to m2x and LX plus MY equal to 1. Y is equal to m2x. Just replace m1 by m2 in the just you have done the coordinates of B is 1 by L plus m1, m1 by L plus m1. What is the coordinate of D? Just replace m1 by m2. Therefore, the coordinates of D is 1 by L plus m2, m2 divided by L plus mm2. So far, you have got the coordinates of A is 0, 0, coordinates of B, also coordinates of D. Now, the diagonals AC and BD, suppose these two diagonals meet at the point E. E is the point of intersection between the two diagonals. E is obviously the middle point of AC. E is obviously the middle point of BD. Now, E is the middle point of BD, whose coordinates are known. Whose coordinates are known. If the coordinates of B and D is x1, y1, x2, y2, then what is the coordinate of the middle point? x1 plus x2 divided by 2, y1 plus y2 divided by 2. Just like that. Use this formula. You can find the coordinates of E, which is the middle point of BD as well as AC. This means that AC passes through the point E also. AC, the diagonal AC, it passes through the point 0, 0. It passes through the point E also. We have known the coordinates of A and the coordinates of E. What is E? AC? AC is the diagonal. Diagonal means it is a straight line. AC is a straight line passing through 2 points 0, 0 and E, x1, y1. Suppose we have supposed the x1, y1. What is the equation of a straight line passing through 2 points? Use the formula y minus y1 equal to y2 minus y1 divided by x2 minus x1 into x minus x1. Just you have put this one. In this way, you can find the equation of the diagonal AC also. Perhaps you have understood this. Now, we are going to solve the equation number 2. Question number 2. Now let us solve the question number 2. First, let me remove this. What is question number 2? The question number 2 is we have to find the area of a triangle. Such type of questions were done in the last year, but we have not done exactly this question. Such type of questions were done. Now I am going to solve this question. We are going to solve this question. What is this? The area of the triangle formed by the lines, these same lines, ax square plus 2ac square plus by square equal to 0. This represents two straight lines passing through the origin. Another line is given, third line is given. All the sides of the triangle is given. All the sides of the triangle is all the sides of the triangle are given. If all the sides of the triangle are given, this means that we can find the coordinates of all the points, all the vertices of the triangle. If ABC is the triangle, we can find the coordinates of A, B and C. Because the equations of the sides of all the three sides of the triangle are given. Therefore, we can find the coordinates of A, B and C. If you can find the coordinates of A, B and C, if all the three coordinates of a triangle are given, then you can easily find the area of the triangle. In this way, we can find the area of the triangle. Suppose this ABC is the triangle. It represents a pair of straight lines passing through the origin. This means that suppose this is y is equal to m1x. It will be y is equal to m2x. And the third line is this, is given to me this. Lx plus my plus, this is Lx plus my plus m equal to 0. Lx plus my plus m, this is good. Now, since the equation ax square plus twice hxy plus by square is equal to 0 represents a pair of straight lines passing through the origin. Let, suppose this is number 1. Let these straight lines, let the straight lines represented by, presented by 1b, y equal to m1x and y is equal to m2x, so that m1 plus m2 we have calculated for many times, minus twice h by b, and m1 m2 equal to a by b. m1 plus m2 equal to minus twice h by b and m1 m2 equal to a by b. m1 m2 equal to a by b. Let y is equal to m1x and y is equal to m2x. Suppose y is equal to m1x is number 2, y is equal to m2x is number 3. Means 2 and 3 are the equations of the sides AB and AC of the triangle ABC. Of the triangle ABC. Equations of the sides AB and AC. Clearly, the coordinates of A will be 0, 0. Clearly, the coordinates of A will be 0, 0 or are 0, 0. The coordinates of A will be 0, 0. Given that the third line is Lx plus My plus n equal to 0. Given that the third line is Lx plus My plus n equal to 0. That is the equation of the line BC. That is the equation of the side BC of the triangle ABC. Triangle ABC is Lx plus My plus n equal to 0. Suppose this is number 4, n equal to 2. Now, the coordinates of A is 0, 0. Find the coordinates of B and find the coordinates of C. Now, B is the point of intersection between the straight lines. B is the point of intersection between the straight lines. Y is equal to m1x and b means straight lines 2 and 4. Solving 2 and 4 we get 2 and 4 we get. Now Lx plus m, for y you write m1x plus m1 equal to 0. This means L plus m1 into x equal to minus m1. This means x equal to minus m1 divided by L plus m1. Now from 2 implies y equal to m1x means minus m1 divided, not m1, it is not m1, it is m. It is not m1, it is m. It is given to be m in the question, it is given to be m. Not m1, it is m. Right? Therefore, the coordinates of B is, therefore the coordinates of B are minus m divided by L plus m1 and minus m1n divided by L plus m1. The coordinates of B is this. Similarly, C is the point of intersection between the straight lines 3 and 4. Similarly, C is the point of intersection. Now, C is the point of intersection between the straight lines 3 and 4. Therefore, the coordinates of C will be replaced m1 by m2 here. Therefore, the coordinates of C are minus m divided by L plus mm2, also minus m2m divided by L plus mm2. L plus mm. Suppose the coordinates of B is x1, y1. It is x2, y2. x2, y2. Let us suppose there. Let us suppose there x1, y1 is equivalent to this minus m divided by L plus mm1 minus m1m divided by L plus mm1. This. And x2, y2, this is equivalent to minus m by L plus mm2 minus m2m divided by L plus m2. Now the area of the triangle ABC is area. Now the area of the triangle ABC is area of the triangle ABC is, what is the area of the triangle? You write the coordinates like this. You write the coordinates like this. This into this minus this into this plus this into this minus this into this plus this into this minus this into this. Area of triangle ABC equal to half into 0 into y1 minus 0 into x1 plus x1 y2 minus x2 y1 plus x2 into 0 minus y2 into 0. We take the area as positive, therefore put the modulus area 0. These two terms will be equal to 0, these two terms also will be 0. It will be x1 y2 minus x2 y1. It is like this. And this is equal to, what is x1? Minus m divided by L plus mm1 into y2 means minus m2m divided by L plus mm2 and minus x2 means this minus m divided by L plus mm2 into y1 means this one minus m1m divided by L plus mm1. This is the area of the triangle, right? This is the area. We have thus put the values of x1, x2, y1, y2 from here. Now you see, it is very simple. What will be this? N into n square, n into n square will be taken, can be taken outside, can be taken common. L plus mm1, L plus mm2, L plus mm1, L plus mm2. You may write this is equal to n square by 2. N square by 2. And in the denominator, you may write L plus mm1 L plus mm. You may write like this. And in the numerator it will be plus m2 minus 3 minus m1, m2 minus m1. m2 minus m1. m2 minus m1. You know the values of m1 plus m2. This is equal to minus twice h by b. m1, m2 equal to a by b. You know the values of m1 plus m2, but it is m2 minus m1. m2 minus m1 can be written as root of r, m1 plus m2 whole square minus 4 m1 m2. You may write like this. This is equal to m square divided by 2. It will be l square plus m into m1 plus m2 plus m square m1 m2, and in the numerator you may write here m2 plus m1 whole square minus 4 m1 into m2. You may write that. This is equal to m square by 2. It should be minus twice h by b whole square minus 4 a by b. It will be l square plus m minus twice h by b plus m square a by b. Right. M square a by b. Write like this. This is equal to m square by 2. M square by 2. In the numerator, 2 divided by b. Take 2 divided by b common. Means 4 divided by b square. Under root means 2 by b. It will be h square minus a into b. H square minus a into b. And in the denominator, take 1 by b common. You will get b l square minus twice h 1 minute is there. 1 minute. It is L into L, L square. L m. It should be L into m. L m m2 L m m1. L m into m1 plus m2. M square m1 m2. It should be right here Lm, because L into L square, L m m2 plus L m m1. It will be Lm into m1 plus m2. Lm into m1 plus m2. Twice h Lm plus am square. Now you see 1 by b, 2 cancel. This is equal to m square into root of r. H square minus AB divided by BL square minus twice H LM plus AM square plus AM square. This. Which is the required area of the triangle? ABC. Which is the required area? Area of the triangle. Area of the triangle ABC. Now you see, you are given the equations of the sides of a triangle. Ax square plus twice xy plus by square equal to 0. It represents a pair of straight lines passing through the origin. You know it. The two straight lines represented by ax square plus twice xy plus by square equal to 0 are of the form y is equal to m1x, y is equal to m2x. Suppose the two straight lines y is equal to m1x, y is equal to m2x. The point of intersection between the two straight lines is 0, 0. Means one coordinate of the vertex A, the coordinates of A, if the triangle is ABC, the coordinates of A is known, 0, 0. Now you can find the coordinates of B and C, because B is the point of intersection between the straight lines, y is equal to m1x and lx plus my plus n equal to 0. You can easily find the coordinates of B. Similarly, you can find the coordinates of C also. Now, the coordinates of A, B and C of the triangle ABC are known. Therefore, you can easily find the area of the triangle. You can easily find the area of the triangle. All the sides equations, all the equations of all the sides of the triangle are given. We can easily find the coordinates of ABC. Therefore, you can easily find the area in this way. Dear students, perhaps you have attended class and you have understood. Today I want to stop here. Thanks for attending the class. Thank you very much. Thank you.